Okay, students, this is Ms. Whitaker, and I wanted to show you today, since we're talking about proportionality, I wanted to show you a model that physically gives you a demonstration of how ratios can be equivalent and how we can use proportions and what we know about them to make predictions. So I wanted to start out with a problem today, and it's concerning this train model. If you'll just take a look at the screen, it says the length of a model train engine is 2 purple rods. It is also 4 red rods in length, and what these rods are referring to are these cuisenaire rods that we're using in class today is for modeling. I've got some over here just as an example. These are meant for filming, but you're going to have some actual rods, and you're going to have different colors, and we're going to use the purple and the red just for this example, but I'm just going to walk you through this. So I've got my purples up here and my reds down here. Now what it says is that the model train engine is 2 purple rods. So what I'm going to do is I'm going to put my 2 purple rods right here to demonstrate what that just says. And then it says right here, it is also 4 red rods in length. So my reds, I noticed, are a little smaller. I'm going to put those reds, and I'm going to put them right underneath. It says that that train engine, that model train, is also 4 reds. So hopefully you can see that pretty clearly. And then I've got a problem down here that says if a flatbed car measures 3 purple rods in length, how many red rods long is it going to be? So I'm going to have to make a prediction. So here's my problem. I've got a model train, and it says it's 2 purple rods, and it also says it's 4 red rods, and hopefully by now you're kind of seeing a relationship between the purple and the reds. So what I'm going to do is walk you through this paper that we're going to be working off of. I'm going to move these out of the way just for a second. I'm going to work on this paper. This is similar to what you're going to see. Now this is called the 4-corner model because we've got 4 corners of work to do. Each corner has its own special purpose. So the first thing we're going to do is we're going to work with the upper right. Just like we would on a coordinate plane, it's quadrant 1, and then we have 2, 3, 4, and we're going to go in that same order. So we're going to start with this area, this blank area, to model it. So what we're going to do is we're going to draw what we just built up here with our cuisenaire rods. All right, so what I'm going to do is I'm going to say that 2 purple is equal to 4 reds, and then I'm going to draw a picture of that. I'm going to draw 1 rod, and that's a purple, and then I'm going to draw another rod for another purple, and I'm going to put P for purple. Hopefully you can see that. All right, and then I'm going to draw the reds. And just like I see up here with the 2 reds, I know that I've got 2 per. So here is an R and there's an R. And then I've got 4 total, just like it told me, 4 rods in length. So hopefully you're seeing a relationship. Now what I need to do is figure out how many reds there are for, in our problem says for 3 purple rods. So let me draw my 3 purple rods. Here's my 3 purple rods. Then I'm going to draw my reds. And that's what this area right here is for, is to be able to draw and model what we're actually doing with the actual rods. So what did I find out? For 3 purples, how many reds do I have? I have 6 reds for every 3 purple rods. And I'm going to write that as a ratio. 6 reds to 3 purples. And I can write it with the word to, right? I can say 6 reds to 3 purples. Or I can write it 6 reds over 3 purples in fraction form. Now I can also write it the other way around. I can say 3 purples to 6 reds, or 3 purples to 6 reds, or 3 purples to 6 reds. All right, so this is my modeling of what I actually did with the actual physical models, the cuisenaire rods. So I can draw it. If I don't happen to have my cuisenaire rods handy, then I can just draw it on the paper and see that. All right, so now we're going to move over to the second quadrant over here, and we're going to kind of make a discovery and see what relationship we have between the purples and the reds. All right, so what did I do? What did I find for my purples? What did I do to get my reds? Well, it looks like I multiplied by 2. And then my 3 here, what did I do for my 3 purples to get the 6 reds multiplied by 2? So let's keep going. What if I had 4 purples? Looks like if I multiply by 2, that would be 8 reds. So do you see, I just had one example, and then I can start making some predictions about what if I had 5 purples, or what if I had 6, or 7, or 8, or 9. I am seeing that the relationship seems to be that I'm just multiplying by 2 with my purples to get my reds. So we're trying to discover this relationship now between the reds and the purples. So let me complete this just like you're going to complete. So here's my written description. What am I doing to the purples, or what am I doing to the reds to get my purples? So I am taking, if X is my purple, then I am multiplying that by 2, and I'm going to rewrite that with 2x to get this value over here for my reds. Okay? So that's my relationship. The red is twice the number of my purples. The reds, well, I should say are. Reds are twice the number of the purples. All right, now that we've figured this out, we want to move down to quadrant number 3, and we're going to graph what we worked out in the table up here. So this is the first quadrant of our coordinate plane. It's got my number of purple rods here on the bottom. It's got my number of red rods on the side over here. So let me do some numbering here. I'm going to finish there, and then I'm going to do some numbering over here on my red rods. I don't have to go all the way up. I'll stop right there. Now, for if I had 2 purples, how many reds did I have? I had 4. So let's plot this as if this were the X column and this were the Y. So if this was my X coordinate, these were my Y's, then I'm going to plot the point at 2, 4. So I'm going to go to my purples. I had 2 purples, and then I had 4 reds. So my point's going to be right there. Then I had, according to my table, I had 3 purples and 6 reds. So when I have 3 purples, I have 6 reds. And there's my next point. When I have 4 purples, I have 8 reds. When I have 5 purples, I have 10 reds. When I have 6 purples, I have 12 reds. And I'm seeing a trend here. It's looking like if I connected these, it would be a straight line. So there's definitely a relationship. If I see a straight line, these points are just going up like this, I know there's definitely a relationship. That just confirms it. When I have 7, then I've got 14. When I have 8, then I have 16. And I bet I could just keep making a prediction. I bet that one would be right there, and that one would be right there. And I haven't even plotted those points. I didn't have those on the graph, but I know where they're going to go because I see a relationship. All right, so now we've graphed it. Now we're going to move over here to the 4th quadrant of our 4-corner model, and we're going to record these ratios. All right, so what we're going to do is we're going to write down ratios of reds to purples. So we're going to go back up to our table up here, and we'll look at our reds to purples, 4 to 2, 6 to 3, 8 to 4. Now we could do it the other way around, but we want to see that because of our relationship here, that the reds are twice the number of our purples, then we want to see what the reds are going to be and what our purples are going to be. But I could do either way. I could go purples to reds or reds to purples. But I'm going to do right here, I'm going to do reds to purples. So here's some of my ratios. I had a 4 to 2. I had a 6 to 3. I had an 8 to 4. I had a 10 to 5. I had a 12 to 6. I had a 14 to 7. I hope that you notice as you're writing all these out that they all reduce to the same ratio. What did they all reduce to? Well, I hope that you figured out that they reduce to 2 to 1. This is the reduced ratio. And it's also the multiplier to any purple I have. If I multiply by 2, that'll give me my reds. All right, so what do all these ratios have in common? Well, we talked about just now that they all reduce to the same thing. So they all reduce to 2 to 1. And we are comparing two quantities, so we're talking about ratios, so that's what this is. We're talking about reds to purples or purples to reds. So we're describing ratios, and we're all finding this relationship that they're all reduced to 2 to 1. So it's a comparison of two quantities. All right, so that is what these ratios have in common. They all reduce to 2 to 1, and they all are a comparison of two quantities, the reds on top and the purples on the bottom. So let's talk about what kind of relationship is shown. Well, we know that when two ratios reduce to the same thing, all of these reduce to the same thing, then what is that called? Starts with a P. It's proportional. It's a proportional relationship. Because these two quantities reduce to the same ratio. All right, so how many can we predict? Let's just throw out an example. How many purples if we had, say, 40 reds? So what is our reduced ratio up here? 2 to 1. Now remember that the reds were on top, so we're going to have 40 on top over here if we have 40 reds, and this is the one we're looking for. So we could solve this different ways. We could say 2 to 40 was times 20, and then so 1 times 20 is 20. Or we can do cross products. 40 times 1 is 40, and 40 divided by 2 is 20. Different ways that we've learned how to solve for this proportion. Or we could actually, if we had our cuisenaire rods, we could draw a picture, or we could use the rods to form a picture. So we know that our X, or our purples, are going to be 20. So 20 purples. All right. So hopefully this is simply just an exploration of ratios and equivalent ratios and ratios that have relationship with each other and how they can be proportional to each other. So hopefully this demonstration is going to help you with the next activity. So let's start working on that.